Alright, so this next piece we are going to look at is compound inequalities. So compound inequalities are going to be two or more inequalities that are joined with either and or. And the or inequalities will usually be graphed apart. So for example, here I want x to be less than or equal to -2. So I would go to the -2, I put my circle. Since it's underlined, I'm going to fill that in. And then I want it to be less than, so we are going to go to the left, and it'll keep going on forever. Or I want my x to be greater than 3. So I go over to +3, I put my circle. Now it's not underlined, so it's not included, and I want x to be greater than that, so I'm going to go to the right. Now for the interval notation, we have to write this twice. So for this part on the left here, the smallest number is our -infinity. So I put my -infinity, and then it goes all the way to -2. -2 is included, so I put a bracket. Or, for this part on the right, we start at 3, not included, so it gets a parentheses. It goes all the way to +infinity. We put our parentheses. So this is an example of an or inequality. Usually the arrows will point away from each other, and we have to write the inequality, or I'm sorry, we have to write two separate interval notations. Now when you solve these or inequalities, you solve them the exact same way that we would solve our regular multi-step inequalities, but the big difference is now we have to solve two at the same time. So for this first one here, I would start by adding 4 to both sides. All right, that will give me x is less than -3, and that one is finished. For the second one over here, I start by dividing both sides by 2. And so that gives me x is greater than or equal to 6. So these are my two different inequalities. I can see the arrows are going to be pointing away from each other. Now I go over and graph them. So for the first one on the left here, I would go to my -3. I put my circle, and the -3 is not included, so I don't fill it in. I want x to be less than -3, so we're going to go to the left. For this one on the right, I go to 6. This time it is included, so I fill in my circle. X is going to be greater than that number, so now we go to the right. And then we have to write our two separate interval notations. So starting with my blue inequality, smallest number is -infinity. So I put my -infinity with my parentheses. The largest number for that blue one, for this one on the left, is -3. Not included, so it gets a parentheses. Or for this one on the right, the purple one, my smallest value is 6, and it is included, so it gets a bracket. Largest value is +infinity, and we put our parentheses. So a little bit more work, because we have to solve the two inequalities at the same time. We have to graph them on the same number line, and then we have to put our interval notation twice. Number 2, same idea. So we start by dividing both sides by -3 for this first one. Remember, I'm dividing by a negative, so now I have to flip my sign. So I have x is greater than or equal to negative divided by negative gives me a +3. I can graph that one. I go over to 3 on my number line, fill in my circle because it's underlined. We go to the right forever because now we had to flip the sign. We want x to be greater than or equal to 3. And then for the second one, start by subtracting 5 from both sides. So now I have x is less than 1. I go to 1 on my number line, I put my circle, I don't have to fill it in this time, and I want x to be less than 1, so that's going to go to the left. So now when I go to write my interval notation, my smallest value is this arrow pointing left forever, so that's going to be negative infinity. I put my parentheses, I draw my negative infinity sign, and then for this first part of our compound inequality, our largest value is 1, but it's not included, so we put our parentheses. Or, now we go to this next part here. My smallest value for this blue piece is 3, and it is included, so it gets a bracket. And then it goes to positive infinity, and it gets a parentheses. And then we're going to do the same thing. If it's a two-step inequality, we just have to solve each one twice. So for number 3, first thing we'll do here, we'll subtract 9 from both sides. First thing we'll do here, we'll subtract 10 from both sides. So for my first inequality, now I have 2x is greater than 8. When I divide both sides by 2, I get that x is greater than 4. On this second one, 5x is less than 10 minus 10 will give me 0. So now when I divide that by 5, 0 divided by 5 just stays 0. So x is going to be less than 0. We go to graph them. So I put my circle on 0, does not get filled in. We're going to the left on that one because I want x to be less than 0. For my other one, I start at 4. Again, I don't fill it in. And then we're going to go to the right because I want x to be greater than 4. And then I write my interval notation. So furthest we get to the left would be negative infinity. And then we go up to 0. 0 is not included, so it gets a parentheses. Or for the second part, our smallest value for this blue part of our inequality is 4, but again, it's not included, so it gets a parentheses. And then it goes to the right forever, so that'll give us infinity. All right, so those are the steps we follow for these OR inequalities. Take a couple minutes, try out 4 and try out 5, and then check and see how you do. All right, so here is what you should have got on those last couple. Sorry, zoomed in on that. For the first one, for number 4, we end up with x is greater than or equal to 2, or x is less than or equal to negative 2. So again, arrows are going to point away from each other. And then for number 5, just make sure you start with distributing for this one on the left. And for both inequalities in number 5, we divide by negatives, so we end up flipping the sign, and we end up with with x is greater than 2, or x is less than or equal to negative 4, and then we graph our two separate solutions. Now with these AND inequalities, the AND inequalities are usually going to be graphed together. So what ends up happening is the two arrows will point at each other, and we'll fill in everything in between. So for example, on this first one, I want x to be greater than or equal to negative 6. So if I went to negative 6 here, and I would go to the right, and we would fill that in. And I also want x to be less than or equal to 1. So that would be here, and we would go to the left. Now for this one, we only want the numbers that are a solution to both of these inequalities. That's what this AND means. So it would be from this negative 6, and it is included, up to this positive 1, and our solution would just be those two numbers and everything in between. So this red part is what our inequality graph would look like. And then this time we have starting and stopping points. So -6 is my smallest value, 1 is my largest value, and they're both going to get brackets. There's no infinities this time because we only want the numbers that work for both of these inequalities. All right, and then usually because the solutions come between them, we can write it more condensed. So for example, this one up above, we had x was greater than or equal to -6, and x was less than or equal to 1. And so we can write that as one big inequality. -6 is my smallest number, x is going to fall in between them, and then 1 is my largest number. So you'll notice that the inequality symbols, they're facing the same way, because here I'm saying I want x to be bigger than -6, so when I put x in the middle, I have to spin that sign around so that we're still showing x is bigger than -6. So usually our and inequalities are more condensed. We've got the part with our variable in the middle. I personally think these are easier to solve than the other ones because I just am doing the same steps. For or inequalities, we might have different steps for each part of the inequality. With and, because we're solving two inequalities but they're pushed together, it's just the same steps. So here when I subtract 4, I just have to make sure I do that to the 9 also, and then to the 2. So now my solution is that -2 is less than or equal to x, which is less than 5. All right, so a little easier to solve. I'm just doing the same step. I have to make sure I do it to all the spaces. -2 is my smallest number. It is included. 5 is my largest. It is not included. And we fill in everything in between for our interval. -2 is my smallest. It is included, so it gets a bracket. 5 is my largest. It's not included, so it gets parentheses. Same thing with 27. Or I'm sorry, with number 7. We'll start by adding 13. We add 13 to the 8 and to the -27. So you just have to make sure that you're doing that to all 3 parts of this inequality. So now we have -14 is less than 7x, which is less than 21. And then we just divide everything by 7. And we end up with our inequality as -2 is less than x, which is less than 3. So I want x to be between -2 and 3. Neither number is included, so it's open circles. We shade in between. And then for our interval, both numbers get parentheses because they're not included. So -2 to +3. All right, so again, try out these last 3, see how you do. All right, so here are your 3 solutions for number 8. -4 is less than or equal to x, which is less than or equal to 2. Both get brackets, both circles are filled in. Number 9, -3 is not filled in, but 6 is. And then for number 10, 5 is not filled in, 8 is. If you don't remember how to solve for number 9, when you have that fraction, we just multiply by the reciprocal. So times 3 and then divide by 2. 4 times 3 is 12, divided by 2. Same thing here, flip our fraction. 2 times 3 is 6, and then we divide by 2. That's how we end up back at our 3. All right, so that's how we solve and graph these compound inequalities.